Welcome to today's Explainer. We're diving straight into the absolute bedrock of plant construction, the foundation check for rotating equipment. If you've ever wondered how massive, multi-ton industrial machinery can run smoothly for decades without literally shaking the entire building apart, well, you are in the right place. And as you'll see, it all starts with the concrete foundation sitting right underneath it.
To really grasp what we're up against here, I want you to picture an unbalanced washing machine on a spin cycle. You know, when it vibrates violently, bangs against the wall, and practically tries to walk across your laundry room floor. Now, take that chaotic energy and scale it up to a massive industrial pump or compressor weighing tens of thousands of pounds. That destructive vibration is the exact enemy we're fighting today. Because if the foundation isn't absolutely flawless, that vibration will literally tear the plant apart.
So here's our roadmap for today. We'll kick things off by looking at the unique vibration problem, then compare stationary versus rotating equipment setups. After that, we'll unpack the anchor box concept, walk through the essential foundations checklist, and finally, talk about why getting this right matters so incredibly much.
All right, let's jump right into the first topic, taming the spin. What is it that makes this specific type of machinery so unique and challenging to install? In plant construction, we typically divide machinery into two main buckets, stationary and rotating. Rotating equipment includes dynamic machines like pumps, compressors, and blowers. Unlike a static storage tank, these machines have internal shafts and impellers, spinning at incredibly high speeds. And this high-speed rotation generates massive amounts of kinetic energy. So to safely absorb all that vibration right into the ground, their foundations have to be engineered perfectly.
Now, to really understand this, let's play a quick game of spot the difference between stationary and rotating foundations.
If you look at a standard stationary equipment foundation, say for a vertical vessel, you'll see thick anchor bolts already firmly planted right into the solid concrete. The equipment is just lowered right onto them. But take a look at a foundation prepped for a rotating machine, like a pump. There are no protruding bolts. Instead, you just have these empty square pocket spaces cast right into the concrete block. So why on earth would engineers leave empty holes instead of just planting the bolts?
Well, that brings us to a really brilliant structural feature that is completely unique to this process, the anchor box concept.
Those empty square holes are called anchor boxes, and they exist for one simple reason. Rotating equipment demands hyper-precise alignment. If you pre-plant bolts in wet concrete, you're permanently locked into that exact millimeter of spacing. But these rotating machines have to connect seamlessly to highly complex piping networks. If the alignment is off by even a fraction, you can't connect the pipes without introducing massive, dangerous stress. So the bolts have to be installed after the machine is perfectly positioned.
You see, rotating equipment doesn't usually arrive as just a single standalone pump. It comes mounted on a rigid metal base frame called a skid, which holds the pump, the motor, and various piping connections together as one unit. If you bolted this entire skid down to inflexible, pre-planted bolts, making those tiny, critical micro-adjustments to align it with the main plant piping would be literally impossible.
So, the huge takeaway here is that flexibility for alignment completely outweighs the minor convenience of pre-planted bolts. By leaving those anchor boxes empty, engineers can lower the skid, perfectly align the pump with the piping system, drop the bolts through the skid into the empty boxes, and lock them in later with specialized concrete. But because of this unique setup, checking the foundation requires a totally different strategy.
Which leads us nicely into the actual on-site procedure. Let's look at the essential foundation checklist and see exactly what we're looking for before the installation begins.
For those new to this, there are 4 absolutely critical parameters you have to verify before you can safely begin erecting the equipment. You need to check the elevation, verify the anchor box spacing, inspect the cleanliness of those boxes, and ensure the surface is ready for chipping. And let me be clear, if even one of these fails, the installation process stops dead in its tracks. First up, you have to verify the top of concrete or TOC elevation. In civil engineering, the concrete is intentionally poured slightly higher than the final required elevation to allow for precise leveling later. You need to check this current elevation against your drawings. Second, you've got to measure the spacing between all those empty anchor boxes. Are they perfectly aligned with the bolt holes on the metal skid that's about to arrive? Because if that spacing is off, the skid just isn't going to fit.
Next, you have to get physical. You need to get up there and actually look down into every single anchor box. On an active construction site, this is a huge deal. These pockets must be completely free of construction debris, stray trash, or standing rainwater. Why? Because later, you're going to pour a high-strength liquid material called grout,
also known as non-shrink mortar, into these holes to permanently lock the bolts in place. If there's mud or water at the bottom, the grout won't bond, and the second that machine turns on, the anchor bolts will just rip right out of the foundation.
Finally, you check the surface readiness for chipping. You're making sure the concrete is fully cured, so you can use heavy mechanical breakers to chip away the smooth top layer down to that exact TOC elevation. This rough exposed aggregate surface is crucial. It acts like mechanical teeth, ensuring that the padding and grout poured in the next stages can bite down and bond permanently.
So, why are we obsessing so much over empty holes in concrete heights? Let's talk about why all of this matters so much in the grand scheme of things. Simply put, skipping even a tiny part of this foundation check is an absolute recipe for disaster. Think about it. If the foundation is too high, your pipes won't line up. If an anchor box is dirty, your bolt won't secure. And if the equipment alignment isn't totally flawless, the mechanical stress and high-speed vibration will physically tear the machine apart from the inside out. We're talking shattered bearings, blown seals, and a multi-million-dollar plant coming to a grinding, highly dangerous halt.
So, the next time you walk onto an industrial construction site and see a massive concrete block full of empty square holes, you'll know exactly what's about to happen. You understand the incredible engineering flexibility those boxes provide. But here is the real question for you. Knowing the incredibly tight tolerances required, are you truly ready to give the green light for the crane to lower the equipment, secure the bolts, and start that high-stakes alignment process? That wraps up our explainer on the foundation check for today. Thanks for joining us, and keep those foundations solid.